Hello guys, today I'm going to be doing a video on scaling in a Delta PLC using ISPsoft software. This idea came after one of the viewers requested on one of my videos that can you please do a video on analog signals and digital signals. So scaling is a critical part when you're dealing with analog signal. So if you have got any area that you are having issues with on a Delta PLC, just comment down below and then I'll do a video dedicated specifically for you. Today I'm gonna do the scaling like I said. So we are going to create a new project together and then I'm gonna explain step by step how this function works. All right, so I'm gonna take you a bit backwards so that you really understand where we are coming from and where we are going. Okay, in any industrial application that we normally experience, whether you are an instrument technician, an electrician, or you have been in the field before, this is the kind of setup that you always have. You have got your process. Your process can be an incubator, it can be a blast furnace, it can be anything, or a fractional distillation tower, anything, or a refrigerator, in fact. So in the process, let's say you are measuring temperature. And when you are measuring temperature, there is a sensor. That sensor, it can be a PT100 thermocouple or a pyrometer, any type of sensor. This sensor, it produces data that is not understood by the PLC straight there and there. So like a PT100, it gives you resistance, a thermocouple, it gives you millivolts, all those kind of things. So in some cases, this data needs to be conditioned like to things like linearization and all those kind of things. So from a process, we put our temperature sensor, and given this process that I have here, we are measuring a temperature range from 100 to 600 degrees. We are measuring from 100 to 600 degrees. So our sensor is measuring a range of 100 to 600 degrees. And then this signal that is produced by a sensor which is measuring this temperature range is then taken to a transducer. Under a transducer, that is where signal conditions come in, like converting one energy to another. Let's say a PT100, you are measuring resistance and then you get 4 to 20 milliamp. On a thermocouple, let's say you are getting milliamps, or then you get 1 to 5 volts like you are getting here. So when our sensor receives the signal, it's giving us 1 to 5 volts. And then this 1 to 5 volts is a signal that is being understood by the analog card that you have on the PLC. You configure your analog card on the PLC. Something that gives you 4 to 20 milliamp. So this 4 to 20 milliamp, you wire it on your PLC analog input. So what does this mean? It means 100 degrees Celsius is proportional to 1 volt. 600 degrees Celsius is proportional to 5 volts. That's what this means. So after the PLC, remember the heart of the PLC is digital. There's a microprocessor. So there is analog to digital conversion. So when you convert this signal into digital signal, we get what you call counts. So the counts that we have here is 0 to 4095. So as a programmer in your program, after you convert this 420 milliamp or whatever signal that you are having, you get what you call counts depending with the bit resolution of your card that you have. So here you are getting 0 to 4095 counts, meaning 4095 count is proportional to 600 degrees. 0 count is proportional to 100 degrees. So as a programmer, you are working with this kind of figures in the PLC, but the operator needs to see temperature. So with scaling now, that what you're going to program here, we are going to be playing around with this signal, but we want to convert this signal so that our operator can see this kind of signal. So now I'm going to take you back to the Delta PLC manual, because you rather know and understand what is really happening so that we are on the same page. So this is our function that you're going to use. It's called SCLP, proportional parameter proportional calculation. I just call it scalp, whatever. So you can see there's a D here. So there is a 16-bit scaling function, and there's a 32-bit scaling function. So the 32-bit is when you are dealing with decimals like 0, which we call floating points or real numbers in programming. So this is the function that we are going to use. So this function has got a source value, parameters, and operational result. That's where you get your result. Our register that we are going to use, we are going to be using D registers. And then the numbers that we can process, since it's a 16-bit, you can scale numbers from minus 32768 up to 32767. That's your range because it's a 16-bit. You get this as well, this type of instruction on a 32-bit, like this one at the bottom here, the number 3. So now I'm going to take you to what you'll be trying to do. It's just simple. It's a graph. It's just a graph like this. So it's proportional. It's proportional. What you put here, you must get it here. So I'm gonna see how we are going to be doing it on the software side now, right? So I'm going to take my function SCLP, right? Press enter. This is a shortcut. You can actually get it even here if you type here all types and then SCLP. You get your function like this. So I just did the shortcut. So load M1000. In my other video, I explained how the load M1000 works. It's just an always on flag. Whenever the PLC moves from stop to run, this bit closes. Okay, so what we have here, we have S1 and then we have S2. Okay, so I'm going to show you how delta instructions works. So I'm going to open a notepad, right? Let me really see what you are trying to do here. Okay, so I double clicked here. This is our instruction, right? It's saying S1 is a source value, S2 parameters, D result output, right? Then we go back to the manual. The manual is saying S1 is the source value. What is the source value? The source value on our question is the source value. Now we are on the PLC side. We are on the PLC. So on the source value, that is where we are wiring our analog signal, where it's coming in. So on the source value, it's in the PLC now. The register that where you are receiving the analog signal. In the PLC, you are seeing it in forms of counts. So this is our source value, 0 to 49. This is our source value, right? So I'm going to go back here. So I'll say source value S2. It's S1. S1 is our source value. S1 is the source. And then what is it? This S1, we are going to call it a D0. That's where we are receiving our signal. It's called D0. Okay, we're done here. We come to our program and then we put a D0 here. D0, which is source. So that signal, when it's coming now from the field, when that value, when our temperature is going up, it's going up from 0 count, 2 count, 3 count. This will be happening in D0. That's the register where we are receiving our analog input. That's the register where we are going to be reading 0 to 4095 count. That's our input register. So now, obviously, okay, let's just move next. I'm gonna confuse you now. All right, we'll go back to our instruction. It's saying S2 is parameters. So S2 is maximum source value. We go on to our notepad. We say S2. What is it? Max source, right? What is max source? I'm going to call this D1, right? What is it? The maximum source is 4095. Right. We go back to the question. The maximum source value is 4095. Remember, we are in the PLC. This is on the outside of the module. These are the counts. After we do analog to digital conversion, we get this. So this is our maximum source value, 4095 counts, right? And then minimum is 0. So what are they saying on S2 plus 1 minimum source value? So what they simply means on a Delta PLC instruction, they're saying S2 plus 1. This is min source, right? This is equals to D2. What they are simply saying is S is equal to D1. So S2 plus 1 is D2, right? And then what value is in here? It's 0. Right? And then we move next to other one, S2 plus 2. It's S2 plus 2, max destination. Max dest, which is, we're going to store this in D3. Our maximum destination is our, now we are converting now. So we are done with this one. So this is our destination. This is what we want to show the operator. Remember, when you are measuring, we are not seeing this value. We are just feeling the heat, but we don't know what it is. And then that signal is transferred to a transducer via transmitter and then back to the PLC. Now we are receiving this in form of counts, but we must show the operator now that what is your temperature. The operator does not understand the count 0 to 49. It's you as a PLC programmer who understand this. So the operator must see the temperature. So this is our destination. This is what we want to achieve. So the maximum destination is 600. The minimum destination is 100. Okay. So this is what you are going to do here. Max dest is 600. S2 plus 3. It's a min dest, which is equals to D4, which is equals to 100. Right. So this is what I'm gonna just put this as it is like this in the PLC. Take note, I'm incrementing from D0, D1, D2, D3, D4, right? But here, I'm pointing on S2 is D1. It's S2 plus 1. It's pointing to the next register. And remember, this instruction that we are working with, it's a 16-bit instruction. So a 16-bit instruction, it can only calculate numbers which are in the range of 16 bits. And a D0 as a register in a Delta PLC, it's a 16-bit memory register in size. So if you're now doing a 32-bit, it means you need 2 registers. So let's say we are working with a 32-bit instruction. It means when we are saying, take note, when you are now working with a 32-bit, it's just an example. When you are now working with a 32-bit instruction, it means where we are saying D1, our next register, this bit will occupy D1 and D2. So the next max source or whatever will be taking D3 and D4 because we are now dealing with the 32-bit, so we combine the registers. So just ignore this. I'm just trying to explain to people who already know some of this kind of stuff, but just stick to this. And then we go back to whatever that we are working with. So now I'm going to have to write my stuff on the PLC now. So this is my source. My parameter starts on D1. So I put D1 here. Right. And then here I put a move. I just type MOV. Right here I put a load M1000. So guys, this information is really helping you to grow. Just click on the subscribe button. Usually for every 5 viewers, you know, I get a subscriber. I hope that person is you. Just click on the subscribe, guys. And also click the like button so that other people, when they are searching for this kind of information, this video pops up first. I'm gonna try to keep it as simple as possible and explain as much as I can. If you've got a question, just comment below. Please just comment below. If you've got any tutorial that you want me to do, just let me know. I'll really take care of that. Okay. I'm doing it old school. This is old school. Let's do it very professional. Let me delete this. Right. Copy. So say paste, paste, paste. Right. So what I was saying, this is D1. This is D1. And then I type here D1. Right. So in D1 is our first parameter. So I'm going to write 4095 into D1. Then I come here and say 4095 into D1. And then my next register is 0. This is S2 plus 1, which is, what is it here? Which is D2. D2. My next parameter, I think, is 600 going to D3. The other one is 100 going to D4. So what does it mean here? D1 is just saying this is where we are starting. So D1 is here. That's where we are starting. That's our S2. So S2 plus 1 is here. S2 plus 2 here. S2 plus 3 is this one. So I'm going to now moving that information, my limits, I'm going to move them. The moment I switch on the PLC, these values are just going to be moved in there. But this guy here, the D0 is our source. Take note. Source. So where we are receiving data. Right? But now, our operator now. Okay, where we are receiving data. And now our operator now in the cabin or in the control room wants to see the information that he understands in the form of information. So our operator is going to see the information in D10. This is just a register of my choice. You can put anything that you want, or on D4 you can put D5. It doesn't matter, both is 16-bit, nothing will overlap. So I'm done here with setting the scaling function. So what it means is we're going to get information between a range of 0 to 4095. And then that information is going to be converted proportionally to a range between 100 and 600. So I'm going to check my communication manager, driver 2 simulator. This is the latest version. Give me a time. This is a driver 2. So I come here, check on my communication. Driver 2 is ready to go. Just a reminder, guys, don't forget to subscribe. Okay. We're downloading. You're seeing it's writing object code. So just ask yourself, what's the difference between object code and source code? It's another question of interest as well. Now I'm online now. Right. Now I'm online. But I've got 0000000. Why? Because my PLC is in stop. So I'm gonna click on run. Must get answers. Right. So what do we have here? It means on D0 we have 0. What is D0? D0 is source value. So on source value, if we have got 0, it means we are on 100 degrees. We go back to our question. 0 counts. 0 counts is proportional to 1 volt, which is proportional to 100 degrees. You see now. 0. And then I'm going to punch in a value that is between 40 and 95. So I'm going to say 40. I'm calculating here on my phone. 40, 95. Let me just say it's supposed to be 96 actually, because we are counting from 0. So divided by 2. What is it? 40, 96 divided by 2 is 2048. Why did I use 96? Because when I count in binary bits, 0 is a state. So we say 1 from 0. 1, 2, 3, 4 up to, so it's 49, 20, 48. So that's our 50% of our signal that is coming. So I'm going to come here and say change present value to 20, 48. So this is the information that will be coming from your sensor. That's the way you see it. You see it in terms of counts. Okay, so I write a value there. You can see it's showing me 350 now. It's showing me 350 now. So 350 is 50% of our range because we are starting from 100. Take note, we are starting from 100. So if you say 350 plus 350, you get 700 minus 100, which is our minimum, you get to 600. So this is very correct. This is very correct. So I'm gonna punch now 4097. We're getting 600. We are there now. Our maximum 98, 600. Because this is a 16-bit. It's not as accurate as a 32-bit. With a 32-bit, you can actually get fractional. That's where you get like more accurate. 4,588. So we are now scaling now. We are now scaling. So your operator is seeing 588. But in terms of your logic, in terms of your logic, you are getting maybe resistance is transduced to milliamp, from milliamp or to volt, it goes to count. So let's just say for interest sake, something has changed. The system, they said, oh, now we're having an issue, now we want to change our range, right? They want to change their range now from, let me do online edit. Come here so that you guys learn as well. Now our range is from 0 to 5,000. And let me just say 10,000. 1, 2, 3. 10,000. Download. Okay. We are back again. We are back again in the game. So what it means, if I have got 40, 98, let me write it on the side here. If I have got 40, 98, I'm getting 10,000 now. I'm getting, if I've got that 20, what was our 50% by the way? I'm forgetting now. I think it was 2048, right? It's taking us straight to 50% of the value. 50% of the value, right? So you see, that's how it works. That's how it works. So why is it when you punch a number like this, sometimes we are skipping, was it 4999? We don't have 4999. Why? This is the reason why they always say there is no like a complete conversion from analog to digital conversion. There's always some information that is lost here during the conversion because of resolution. The more you minimize the error is, the less the more, I think, the more you minimize the error, the bigger your resolution. If you have got a high resolution, you've got a small error, you become very, very accurate. I'm going to do a video on that where we're going to do a process from how the PLC converts from this to this. It uses this 12-bit resolution here. How a PLC converts information from voltage to counts given a specific resolution, and doing calculations without a PLC, doing it manual. I'm going to do a video on that as well. So if you've got any question, guys, don't hesitate to ask, don't hesitate to comment in the comment section, then I can clarify. Maybe personally you put on your email, then maybe I can help you directly if you've got a certain issue. So just change your limits. If you change your limits, you get your proportionality. depending with what you have. You can change the limits of the input signal, let's say from 0 to 5,000 or whatever. It gives you that proportion. It's direct proportional. So this is how we scale. This is a simple scaling in Delta PLC. Thank you guys. Don't forget to click the subscribe button. Thank you again.